Hello everyone, hope you all are doing good. So let's start today's video. So today's GFG POTD is about serialize and deserialize a binary tree. Now the question has asked us to complete the functions serialize and deserialize. So what does these two functions do? Serialize function stores the tree into an array and returns the array. Fine. Deserialize function deserializes the array to the tree and returns the root of the tree. Now what does this mean? This means that we need to reconstruct the tree using the array that we have got from this serialize function. And the tree that is reconstructed should be similar to our input tree, and after that we will return the root of the tree. So let's see how can we solve this particular problem. So this is our tree. We will need a vector answer to store the tree. Now to store the tree, we need to traverse this whole tree. So which traversal to use? We will use pre-order traversal. Now you may have one question. Why only pre-order traversal? Why not in-order and post-order traversal? So I will explain you at the end of this video. Now let's proceed forward. So pre-order traversal follows root, left, right. This is how it traverses the tree. So what is the root here? The root is 10. Push this 10 into your vector answer. Move to the left. What is the root here? It is 20. Push this 20 into your vector answer. Move to the left. What is the root here? It is 40. Push this 40 into your answer. Move to the left. What is in the left? It is null. Push this null as -1 in your vector answer. Move to the right. Again you are getting a null. If you are getting a null, whenever you will get a null, you will mark this as -1 in your vector answer. So mark this as -1. Now you have traversed this route. You have visited this left node. Now you need to visit this right node. So the root is 60. Now push the 60 into your vector answer. Move to the left. You are getting a null value. Push -1. Move to the right. You are getting a null value. Push -1. Okay, so this subtree has been traversed. This is the root. This is the left part. Now we need to traverse the right part. So what is the root in the right side? It is 30. So push this 30 into your vector answer. Move to the left. You are getting a null value. Push this -1. Move to the right side. You are again getting a null value. Mark this null value as -1 in your vector answer. So this is what you will get after traversing the whole tree, and this is how you will implement the serializable function. Now to implement the deserialize function, what you will do, you need to reconstruct the tree similar to this input tree using this particular array. So let's reconstruct this. Traverse this whole array. This is the first element that is appearing. Push this in, insert this in your tree, insert this as your root node. Move to the left. 20 is, you are getting a 20. Insert this in the left side of 10. Move to the left. Insert the elements to the left until and unless you get a -1, because -1 means it is a null value. So what is after 20? It is 40. Push 40 in the left of 20. Insert 40 in the left of 20. Move to the left of 40. What are you getting here? You are getting a -1, which means a null value. No need to insert this. Move to the right side. You are getting a -1 in the right side of 40. That means it is a null value. No need to insert. Okay, so return. Now what? You have inserted a left node in the left side of 20. Now you need to insert the node in the right side of 20. So what is after it? It is 60. Insert the 60 in the right of 20. Again move to the left. You are getting a -1. -1 means null value. Move to the right. You are getting a -1 again. -1 means null value. No need to insert. Return. You have inserted the left node. Now you need to insert the right of 10. So insert the node right to 10. You are getting a 30. Insert this in the right side of 10. Fine. Move to the left. You are getting a -1. -1 means null value. No need to insert. Move to the right. You are getting a -1. -1 means null value. No need to insert. So what? This is what you will get as your tree. Now this is what you will get as your tree. Fine. So is this particular tree similar to the input tree? Yes, it is similar. So that means you have deserialized your answer. After that, the driver code will take care of the in-order traversal and you will get this as your output. So now, earlier we had a question why we are using this pre-order traversal and why not in-order and post-order traversal. So let's see why. So here, if you will do the pre-order traversal, the in-order traversal and the post-order traversal of this tree, you will get this as your pre-order traversal, in-order and post-order traversal. You can do it. So here, if we use this in-order traversal, what is the root of the tree? The tree is starting at the root 10. Find the root. Is it present here in the extreme of this, is it present at the starting of the array or is it ending here? No, it is not. So that means in order starts from the left node first, then root node. So won't you think it will be difficult for us to reconstruct a tree with this traversal? As here in pre-order, we knew that this is where our tree will be starting because it follows root left and right node. But here, since in order it follows left root and right node, so it won't be possible enough to get our first node where we will start constructing the tree from. So in order traversal will get rejected here because we are not getting the starting node and it will increase the complexity. So let's reject this. Now, what about post order? Okay, so this traversal can be used for serialization and deserialization. You start with this root here. We are getting this start root. So we can use this as our start root because this is 10. As in post order, what happens? It follows left right root. So the root will be present at the last node. So you start with the root from the last. But from here, determining which will belong to our left subtree and right subtree is difficult. So it will again become complex. Then there comes this pre-order traversal, which can be considered as the best method for serialization and deserialization because it follows the traversal root left and right, which aligns with the way the tree is constructed. That is, it first creates the root node, then it inserts the left node, then it inserts the right node. So we know the starting root here, so we use this pre-order traversal for this serialization part and deserialization. Now let's implement the code. So we are creating this vector to store our tree. Let's create a function called solve and pass this root and answer. After the traversal, we will return our answer. Fine. Void solve node star root. Now what? We will implement here the pre-order traversal. What we will do whenever we will get a null value, what we are going to do? We used to push the null value in the form of -1. So we will push -1, then return, and then we will push the root data. Then what? Move to the left, move to the right. Fine. So this pre-order traversal, the serialize function has been implemented. Now let's move to the deserialize function. So we will keep the elements indexes 0. Index starts from 0. And we are using this value variable to store each element. Increment, move to the next element. Now if my value here becomes -1, that means it is a null value. Then return a null. Or else, if it is not null, what you will do? You will create a new node and insert the value in it. After that, what you will do? Move to the left part and again insert the node. Move to the right part, again insert the node. So this is how you will deserialize. At last, return the root. That is my new node. Fine. Let's compile and run. Okay, deserialize was not declared. Okay. So the compilation has been completed. We are getting correct output. Now let's submit. So the problem has been solved successfully. Now let's end the video here. Hope you have understood today's POTD explanation. If so, please do like and subscribe the channel, as gaining a subscriber and a like in my videos does motivates me a lot to be consistent and create more such content. So do subscribe, like and share this with your friends. If you have any doubt, you can ask me in the comment section. I'm always there to clear your doubts. Thanks a lot for watching. See you guys again tomorrow.